Very happy to be here. I'm Yishai from Learner and I'm going to talk about optimizing non-coding time. So a little about myself. Started my programming career way back in elementary school with Logo, went through learning C, and then later on when I started my professional career, I spent most of it doing contracting, expert solutions for various dev shops. And about 8 years ago, I joined a cloud security startup where I headed security research and worked in the CTO team. And then after an acquisition by Cisco, eventually spent time leading that site. And about 2 years ago, I joined LearnerB, and I'll talk mostly about optimizing non-coding time. I'll talk a bit about LearnerB and what we do there, and how we help developers with these concerns. So developer productivity or software delivery intelligence, many ways to call this area of how do we know how we are doing? How do we know that my dev team or my work as a developer is actually efficient, is actually going well? A ton of people care about this. We're seeing a growing interest in a or like heated debate about why this matters, how we should be doing this, where are those inefficiencies. So I'm just highlighting the way we feel this interest coming from dev leaders across the board in this amazing lineup that we have in our Interact event next month. But mostly I wanted to share that where maybe 2, 3, 5 years ago, almost none of the dev leaders' attention was focused on these areas. Now we're seeing everyone is talking about this. Everyone cares. And I'm going to, in my talk today, shine a light about some area that developers care about, that leaders care about, and where a lot of waste and inefficiency is happening in that process where we create value through writing code. So let's talk about the developer productivity paradox. And what I mean here in this is that there is so much energy and so much, tooling and innovation and ideas and really amazing technology and products being built around the coding, around what I do as a developer when I write code, help me do that more securely, help me code faster, help me codify things that used to be IT or services, help me move that with a shift left motion to be part of my code, and so on. So a lot of great energy there in open source and in commercial products, all focused on how to code better or how to move more stuff to the code. But if you look back at your day as a developer, you're asking how much of my time is actually done, actually spent coding. We see, and it's a pretty common view that, maybe a third, maybe a fourth of the day is actually spent coding, actually building value through coding. And all the rest is the non-coding time. We have meetings, we have tasks and bookkeeping work just to make sure all the data is aligned. We have a lot of code review work, and I'm not directly coding, but I'm helping the code get better. I'm helping the code and the code base evolve. So much time is spent non-coding, and every developer knows that if they can get, 90 minutes of productive coding a day, that's going to be great. So we're spending a lot of time, a lot of energy as an industry in helping the coding part. What about the non-coding part? What about that much larger chunk of my time, which is not spent coding? And if we're thinking about this as an optimization problem, then are we optimizing the important parts? Every developer out there is probably a story or a memory where they spent a lot of time optimizing early and found out they were optimizing the wrong thing and the wrong part. So, as an industry and as developers and as leaders and everyone in between, are we focusing our efforts to optimize what really moves the needle in our workday and in how we provide value? And we're under indexing on the right hand side. How do we optimize? How do we streamline all of the other things so that I can eventually spend more time coding? And if I'm optimizing the larger part of my day, that optimization is going to be more effective and more impactful on my eventual both my personal well-being, but also the value I can bring and the value the team can bring to the world. I'm going to talk about the pull request paradox, and this is a part of the non-coding time during everyone's workday and work week, but a very crucial one as developers. So we have a conflict of interest, if you like. I'm working on something. I just fixed a crazy bug or created this great new feature with tons of value. I want to get it out there, push it to production, get it in the hands of customers, let the world see the value, and move on to my next thing. So my interest is to push this as fast as possible, and my focus is on completing this, getting this reviewed, getting this merged, and eventually deployed. But the people that will help me do this, the people I work with and rely on for the code reviews and for the pull request cycle, they're also doing a pretty similar thing with their features, bugs, fixes, whatnot. They also have important problems they're solving. So their interests are not always aligned, at least not in the micro part of the day, with what I need right now. I need them to review my code. They need to focus on their stuff. And what typically happens is if I wait for the next day, or eventually someone, that person who was busy doing their work are now free to review my code and now have questions or comments about my pull request. I have already moved on to something new. I want to push value, and if I'm waiting for someone to review my code, I probably start a new thing. So when those comments arrive, when the review arrives, there's also a conflict of interest, because now I have this other new thing which I'm invested in, and this older feature or pull request is now something in my backlog that I need to push it, but I'm already heads down into something else. So we see this constant micro conflicts of interest and priorities that really hamper the work on new code getting deployed. A little about the some data that we have pulled from our LearnerBee Labs, our data science team, just to highlight a bit more, with numbers, what happens with pull requests. So if we're looking at the cycle time, the whole cycle for a typical software development item, and we look at a specific branch which gets commits through coding, and then eventually a PR is created, a PR is picked up for review, gets reviewed and merged, and eventually deployed. That whole cycle, on average, and we see that across our wide range of LearnerBee customers, is around a week. Some teams that do this much faster, some teams take much longer, but roughly 6 days in some. Of that, the actual pull request cycle, which is when from the pull request getting raised until it's merged, this is just a pull request review, fixing comments, and eventually merging it, takes about 2/3 of the time. So a lot of the time that it takes for new code to get created and eventually pushed all the way to value, 2/3 of that time is spent in the pull request cycle, in the pull request review, responses to the review, and eventually merging. That's a lot, and that's why we focus on pull requests and the cycle within it as a core area to optimize. And if we study this further, again, looking at a little shy of 250,000 pull requests from a very varied group of developers, we see that those pull requests are idle most of of their time, or at least a large chunk of their time. Half of the PRs are going to spend their time idle for half of their lifespan, from PR created to merge. And when we say idle, we mean no one is looking at it, no one's thinking about it. It's not in anyone's context right now. Excluding nights, excluding weekends, is just work hours. So a lot of time where this PR gets nothing. There's no value happening. No one's it's not even fresh in anyone's mind. And a smaller part, but even like a sizable third of the PRs are going to be idle for almost 80% of the time. So this very started approach where there's a burst of activity and then a lot of idle time, and then, okay, someone gets back to it, does another small thing, then a lot of idle time. I think it's obvious that this is ripe for optimization. And there's, the team is not idle. They're working on other things. But if you look at it from the PR perspective, that PR is languishing and no one's actually looking at it. And when we studied the idle time on PRs, we found two key types of idle time. One is the transition, where in pull requests, you typically need multiple people to interact, typically in async modes, where I put up a PR for review, ask people to take a look at it, then they, at their convenience, do that, give me some comments, which then I read, and so on. So transitioning between people, where the ball moves from me to the reviewer and then back to me, then maybe someone else. All these are transition periods. And transition in many cases also causes idle time. Why? Because I have just moved the ball. Now the next person, they're not free. They're not aware of the new PR until they actually pick up that ball and continue to work on the PR. This is idle time, right? No one's looking at it. No one's working on it. So transition is caused, and the delays here are caused by the actual act of handoffs, the fact that communication is hard and is harder in a distributed, remote first dev team. And because of that clash of priorities, people have other things to do, which are more important to them right now. So it's not always easy for them to take this right now and have a shorter transition time. Another reason is that on the surface, all the PRs are they look equal. I get some link or some email or some notification, or someone hollers at me, take a look at the PR. I don't know what's in it. So I don't know if it's going to be small or large, complex, simple. And when everything looks the same, it's hard for me to prioritize. And now, why is transition time bad? Why does it hurt my team's productivity? Because the longer I wait to get some review back on my PRs, the more context switching I have to do. I have to reload in my mind. When I get the review a day or two later after I finish coding, I need to remember what I did. I need to go back to my code, reread the comments. It's not fresh in my mind like it was 2 days ago when I finished coding and created the PR. The second type of idle time is what we call distraction, where the same person is working, but they need to step away. They need to do something else. So I may start reviewing a long PR, then I have a meeting. And then in 2 hours, I get back. I need to reread some of the code that I've already read. I need to reread my comments, see if I missed anything. All that reloading of context when someone gets back to work after a long pause. A bunch of research showing this takes on average about 20 minutes just to get back into full context of of some task. So every time this happens, every time I start working on something and then need to break and get back, either overnight or over lunch or a meeting or any other priorities, all of these are going to cost a lot in terms of context switching, in terms of that rereading and realigning myself with what I'm doing. So again, an area that if we can remove or reduce some of that, that's going to be a net gain. Some may ask, and some do ask, like, why do we even need pull requests? There's approaches where just, use CI, have great tests, employ great developers, just merge directly to, your main branch. No need for a code review. Just, have good enough infrastructure to do that. And then another alternative is to say, hey, not all PRs are the same. There's the ship, show, ask model and a bunch of others where I could say, okay, some PRs, let's do the whole review process just like we were used to. Some other, that's like ask. I'm showing my code, asking for approval. In some other cases where maybe the change is smaller and safer, let me create a PR and merge it directly myself, but tell people I've done it. So yeah, show that, let people give them the opportunity to look at the changes after they've been merged and do if they like to inquire more, they can do that. But it's not, I'm just showing, I'm not asking. And then smaller changes, easier changes, where we just ship. Just, make those changes directly. No need to tell anyone or ask anyone. So ship, show, ask is a way to segregate the whole PRs or the set of PRs to those 3 lanes. And these are all, good alternatives for teams that find the ways to work this way. But if I'm looking at the broad question of the pull request process, which is pretty much the standard today across most teams writing code, started from open source and very distributed, loosely coupled teams, but now is pretty much mainstream for companies and commercial teams and others that are building code together. There is a lot of value in having those lightweight reviews, just a peer looking at my code, making sure that code quality does not deteriorate, and you can actually even improve through pull requests. And also the fact that, looking at developers across the world, we don't have enough. The demand for developers is growing, and we will have more developers, more young developers, more novice, junior developers joining teams, and this is not going to change 10 years from now. So pull requests are a great way to deal with onboarding new people into teams and into code bases, with dealing with varied levels of skills, where someone maybe needs to look at code coming in from a less experienced developer until they've ramped up and so on. So we don't see pull requests going away anytime soon. Maybe in the edges, some optimizations like the ship, show, ask model for some teams and so on. But this is here to stay as a mainstream mechanism for teams to deliver changes to code bases. Okay, so how do we how can we optimize that pull request cycle? So one obvious very glaring piece of data that we saw is that when developers know that this pull request is small, when they have the right context and they know that the review time is going to be short, we call this estimated review time. I'll talk about this in some of the future slides. When developers know that the PR is going to be small, they jump on it much more quickly. So if you give them the signal that lets them understand this PR is going to take you 2 minutes or 5 minutes or 12 minutes to review, or that PR requires 30 minutes, 60 minutes of your time to review, their response on when do I do this and how quickly do I start is dramatically different. So you can see here small PRs which we provided the reviewer with context, telling them this is going to take you less than 15 minutes or less than 7 minutes. They began to review this within an hour or two. But the larger PRs where the context was this is going to take you an hour, sometimes waited 2 days, because I need to find an hour. I need to find the time. I need to schedule some consecutive time to be effective in my review, which is a good thing. This lets the quick PRs move faster, and only the large and bloated PRs need to wait until someone actually goes in and deals with them. So the obvious but immediate optimization you can do for the PRs in the PR review cycle to happen quickly is to have small PRs. This is probably not a surprise for anyone, but we have the data to show how this affects the PR review cycle. Small PRs get picked up faster, they get comments faster, they get fixed faster, and they get merged faster. So by breaking your work into small chunks that can be reviewed and merged independently, by making sure that refactors are separate from new value, and eventually by deciding together with the team on like working agreements. We'd like all of our PRs to be under 200 lines of code, or find a way to collaborate with your developers and your team to decide this is how we do things. This is important for us. So let's make sure our PRs are tight and small, and then we can easily talk about reviewing them much faster and merging them much faster. Then the question of context is crucial. When all PRs are treated equally, it's a link. You go, click to get to GitHub and see that wall of red and green, and then decide what to do. That's a surefire way to make sure that PRs are delayed and get reviewed much later. By providing context, you can let your teammates, which need to review your PR, know when to do this, how quickly to, or should I stop doing other things and move to this? When, how much time should I allocate for this? So if you can surface context on the review request about like, what is this linked to? What kind, is this a bug? Is this a feature? What is the story or the ticket behind this in Jira or whatever, wherever you manage the work? What's going on in this PR? What are the risk areas? What have I done here? Even information like test coverage and estimated review time, like I mentioned, if I can tell you in advance, this is going to take you 3 minutes, that's great context that will really help push things forward. So find those ways to create context and put this on the envelope of the PR request, and make sure that the reviewer can see this before they need to make a decision on whether I'm doing this or not. Another thing that bubbled up from our data is that there is a crucial gap between PRs that begin and finish in the same day. Like PR is created, then gets a quick review, and then can get merged during that day, and PRs that have to wait overnight. And we're seeing that when PRs wait overnight between created and merged, a much higher percentage of those is going to be idle for a lot of time. Again, excluding nighttime. This is just work hours. But once your PR is already waited, everything is going to be slow about that PR. Now it's like in the back lane, and everything will be slower. The review, the ping pong between people, and eventually the merge, they will all suffer because of that initial delay. So a very practical tip, find a way to open the PR in the morning. You've finished your work, you've coded, find a way to make that PR early. If you have many things to juggle during your day, try to make the PR creation early in the day. And if you're distributed, think about what the day means for your team. Sometimes it's not your day, but get that PR early in the day so that people can review quickly, or at least begin the cycle quickly. And this will make your PR eventually move faster. Another important thing to look at is moving some of the important PR reviews from async to sync. The PR process or the cycle is typically asynchronous, and all that leads into a lot of idle time, a lot of switches. For those PR that you really care about and where they're not terribly simple, consider how you can move them to sync. Pull someone in or find a way to schedule that so that you can review this together and skip a lot of the back and forth. This only needs to happen for a select few of the PRs, but that's where you win the most. So in some cases, the context switch to make the two people sit together on a PR is worth it. And by moving faster, you're actually creating more stability in the process. In terms of tooling, um, if I, as the person that created the PR and sent it to someone for review, when that person is now free and they're beginning to review, I want to get notified. Right? Let me know they're in my PR now. Remember, this is my first priority. I want to push that PR forward. If I can be notified that they're starting the review, maybe I can do the context switch and join them. So I can say, hey, you want to sit this together? So they are controlling their time, but since this is my first priority, I can be more flexible. So maybe, huddle, find a room or whatever, and, cut a lot of that back and forth using a synchronous PR review session. So some ways on how to achieve all of what I've said. Like, how do we surface context? How do we improve communication so that people know they have work, PR review or PR comments, or the next step in the PR is waiting for them. So one option is to do some automation. You can build some form of workflow bot that gets information from GitHub and from other sources, maybe sits in the Slack or in the IDE or MS Teams and talks with developers, lets them know, hey, you're up now. Here's the context you need. You have a PR waiting for you. Here's what you need to know. Someone has started to review your PR. All of that makes a lot of sense in a smart workflow bot. You need to make it customizable. You need to personalize it so it knows what, when am I free? When is the best time to let me know about things? What kind of context I need, and so on. So the pros on like building this is that you can really tailor it to your team's DNA, to how you like to work, to your culture. Not all behaviors are the same or desire to be the same across different teams and different orgs. The downside, of course, it's hard. You need to build this with a substantial level of intelligence and customization. And can you justify the ROI of actually building it? Another option is to leverage what you already get from your Git provider. Your pull requests live on some Git provider. So that's pretty straightforward. You don't need any special permissions or bringing in third-party software. Most of these providers have decent notifications or integrations with workspaces like Slack and so on. The downside is typically that these are going to be limited to just one source of data, just Git, or like just GitHub. If I'm using GitHub and Jira, I'm not going to get the full context from GitHub. If I'm using the Atlassian Slack, it's easier because everything should be integrated. But also, these are typically what we find out there. They're surprisingly hard to customize and configure to really make this match how I want to work as a developer and how we want to work as a team. And if we're looking at the existing tools that are out there for optimizing developer workflows, then there are various gaps, starting from being noisy because it's hard to control when and what do I get as notifications. Need to really learn how to use them. Typically, it's limited to just one data source. It's like a vendor integration to Slack will typically have information from that vendor. And they are not very personalized and customizable. They're just, looks the same for every developer. So eventually they become notification bots, not really improving productivity. The way we have done this in LinearB, and this is basically taking the workflow automation bot and justifying the ROI by focusing on that's what we do. And we are addressing all of these concerns, like cutting down the noise by only showing you what you should be caring about and only at the right time, learning how you work and providing you an estimated review time, really precise context that's going to help you make decisions, pull in information from different data sources, so different parts of the development process. So can I correlate the Git work with my projects, with my releases, with my tickets, and so on. And also makes sure that it adapts to how I work. And if I don't want to do this now, I have some support for doing this later. By investing effort in making this smart, that makes the difference in having like developers actually adopt this, actually like this, and use this daily to cut down on their idle time on the PRs and make the entire cycle run much faster. I want to double click for a minute on the estimating review time. So this is looks like a small feature here in our Workreview bot that tells you for this pull request, which you got a review request for, this is going to take you 6 minutes, or between 2 and 5 minutes. So small footprint, but a lot is happening under the hood, and a lot of value for the review process. As you recall, I've shown that the developers respond to this information dramatically, and they, if it's a small PR, they will do this much more quickly than beginning to work on larger PRs. So we've invested some effort to use our data to create a model. This is a pretty simplistic machine learning model based on a lot of data. This is a supervised learning problem because we have data about actual reviews happening, but lots of challenges because that label is noisy. I wanted to highlight the two types of classes of features that have surfaced as important features affecting the estimated review time. So there's the PR features, starting from the obvious, like how large is the PR, how many lines of code have changed, but going into how many files, which file types, like the variety of file types in a specific PR, additions versus deletions, and so on. And one interesting finding that we saw when we looked at file types is that the data shows pretty strongly that Java takes longer to review. For a line of code or for 10 lines of code, Java will take longer than Python or TypeScript or others. Can't say that we were shocked by this, but really interesting to see this surface in the data. We did not expect to see that kind of signal across like programming language, for example. Then the other type of features are more around personalization. Like if I know who you are as a reviewer or who issued the PR, these are signals that will help me estimate how long it's going to take to review. Also, if I know which repository or which organization, well, who's the customer. So we use encoding to get all of these high cardinality features into the model, and we have this mix between the features on the PR and features on like who's doing it to provide a pretty good estimate that, again, developers respond to, and it really helps push forward the cycle. Couple of examples of things that are coming soon, just to give you an idea of how we're thinking about optimizing your workflow. Most of the talk was about the pull request cycle, but that's not where things end. So if I can save the developers, one or two clicks, moving to another screen, doing another mental switch to complete a task, I've won, and they're happy, and the process is shorter. So if I got an alert from Workreview telling me my PR was approved, and I would go and merge it. Why should I click back to GitHub just to click it? So a click button directly in Slack, a merge button telling me, allow me to just merge this and move on. I don't have to move away to GitHub to complete what has now become a technical mundane task. Similarly, if the PR is very small, and we've all seen those very tiny PRs, 1 or 2 lines of code have changed, why should I go to GitHub to from the alert just to review it? So I get the snippet directly in Slack, and I can click approve, or go to GitHub to start reviewing it. If I need to provide some comments and changes. So all of these small things save another click, save another screen change, and over time this accrues to save the developers dozens of minutes a day. Another area where developers spend time on non-coding tasks and really don't like it is around ticket housekeeping. We've looked at a bunch of data, and even in teams that are very well disciplined, or at least they say they are, about 30% of branches of Git work is not connected, not correlated with Jira or the project information. So developers want to do that. PMs and developer and team leaders want everything to be aligned, but the reality is that it's not. And there is this vicious cycle where developers don't typically like to update tickets, update status. I finished something, create a ticket for this new immediate bug that I found. So developers don't love going into tools like Jira to update status or to create tickets and to make sure that work is aligned. Managers need that, so they keep interrupting developers saying, hey, I need more context. Is this ticket done? Is this ticket merged? Is this ticket, like, what is the status of things? And why are you working on something that's not even in Jira? And then the data suffers because planning and estimation are inaccurate. And when developers need to do all of that, they have less time to build. So this is like a cycle that, gets worse. Okay, how to solve this? How to make sure that all my work is correlated nicely with projects, tickets, but without causing or requiring me to go and do those things I don't like. Again, you can build a workflow bot. Typically, what we see is teams create some merge gates or PR checks that make sure, this PR cannot get merged if there's no ticket. But that's late in the game. Like, now you're like blocking me at the last step. You're late, and the dev flow is hurting. Our approach is to make this happen much sooner. The minute you put up a PR that does not have a Jira ticket or a project management ticket connected to it or to your commits, we will do things. We will let you know directly in Slack that there's a gap, and we will give you a one-click ticket creation. We already know to create the ticket for you. We have information from the PR that we can create a good description for them from. Just click and you're done. Everyone is happy. We've saved you a minute in context switching and going into tools you don't like. Everything is streamlined. So that's another example of optimizing non-coding time to make sure everything happens together. So that was my talk. I touched on the pull request process as a major part of non-coding time and a major thing to optimize to get the developer productivity and the team productivity up, how we reduce idle time by using tooling, by using automation, by surfacing context. And then how do we also address other mundane non-coding tasks to make sure developers are happy, and continuing to focus on those non-coding tasks will create more time for coding and more time for value. Happy to take questions if there's any.